Okay, so P7.3, changes in the nucleus. So I'm going to talk to you about 3 different types of radiation, alpha, beta and gamma. But before we can get onto alpha, beta and gamma radiation, we need to understand the nucleus. So if I give you the example of a helium nucleus, you'll notice that a helium nucleus has got these 2 numbers, 2 and 4. Well, what do those 2 numbers mean? Okay, so if we zoom into a helium nucleus and we can have a look at it, and we can see that inside the helium nucleus we've got 2 green, 2 purple in this example. Okay, and the purple ones, I'm going to say they're the positive ones. They're your protons. Okay, so it's got 2 protons. And it's got 2 green ones. These ones we call neutrons. Okay, so this 2 here is this 2 here. The number of protons is that one there, and we call that one the atomic number. Okay, and then if we look at the number of balls that we've got in total, we've got 4 balls in total. We've got 4 things that weigh something, which means that we've got an atomic mass of 4. Okay, so if we do another example, and this time we're going to pick a random element, so we're going to say element X, and we're going to say that X has got 7 here and 10 here. Okay, and then we need to draw that. So remember that this 7 is the atomic number, and that tells you which element it is. That means it's element number 7 because it has got 7 protons. And they are all positive. And we also know that it must have a mass of 10 . Okay, so my question then becomes, what have I got left? Well, I must have 3 neutrons. Okay, so I must have 3 neutrons because that will give me 10 balls in total. So I've got 3 neutrons. So this number here is how many protons. That tells you which element it is. This number here, that tells you how many neutrons. Now, I could have another element, and let's say this time I had 7, 15. My number of protons is going to stay the same because my atomic number hasn't changed, but my mass has changed. So now if I draw my 7 positive, and I need to get up to 15, I do 15 minus 7, which means I've got 8 neutrons to add. And that is now my new element. Okay, so, and this one here, these 2 are the same element because they've got the same atomic number. It's both equal to 7, and so this one is called an isotope. Okay, so if you've got the same number of protons but a different number of neutrons, then you are an isotope of the same element. Okay, and what we're going to look at today is we're going to look at how does that mass number and how does that atomic number change when you emit radiation. Okay, so the first one that I'm going to talk about is an alpha particle. So if you look at an alpha particle is made up of 2 protons and 2 neutrons. So if I wanted to put the numbers next to this alpha particle, I would say it is 2 and 4. So that's what an alpha particle is. Okay. Now, what we'll come on to in another lesson is what happens to the atom that you started with and the atom that you ended up with if you emit one of these. But just for now, I just want you to know that that is what one is. It's got two particles, it's got two protons and two neutrons. The next one is a beta particle. Okay? And all a beta particle is a fast-moving electron. Okay? And that means its numbers, well, an electron has got a negative charge, which means it's got a -1 proton number. And it doesn't really have any mass, it's got virtually zero mass. So this one is a 0 in the mass part. And then the third type is one known as a gamma ray. Now a gamma ray is just an EM wave, and when we do waves, you will know what EM wave means. But all you need to know is it's like a ray of light, but with more energy. And that means that because it's just like a ray of light, it means it's got no charge and it's got no mass. So that one's 0 and 0. And all a gamma particle is a way of getting rid of extra energy. So energy that you're left over with. Okay, so now that we know what the three types are, the next stage is to look at how do they change when we emit different types of radiation. So, if you're emitting alpha radiation, so let's say you start off with an element such as X 98238, and you emit some alpha radiation. Now we know what the numbers are for alpha. We know that they're 2 and 4 because it's got 2 positive, 2 neutral, which means you've got 4 in total. Okay, and we know we started with 98 and 238, so that means that we must have a new element here. We'll call that element Y, and we know that whatever we've got on this side must add up to the 98, so I want two numbers that add together to equal 98. So I do 98 minus 2, so that means 96, and I do 238 minus 4 to give me 234 on the bottom. And what that means is that the new element has got 96 protons left and 234 in total left, which means that the number of neutrons that it has got left, so Y has 234 minus 96 neutrons. Okay? And that way we can see how it's changing. And the key thing is that these two numbers must add together to equal this number. And these two numbers must add together to equal this number. Okay, now let's say that instead of emitting an alpha particle, instead we emitted a beta particle. So 98238X goes to, and remember what we said about a beta particle? We said a beta particle was just a fast moving electron. And we said that an electron's got a negative charge, therefore it's got a -1 proton number. And it's got 0 mass. Okay, so that means that I now need two numbers here. So -1 adds something equals 98. So 98 minus -1 gives me 99, and 238 minus 0 is still 238. So all I've done is change this number here. So I've just gained a proton. And that would be element Z. Okay, so I've created another element. Okay, and I've gained a proton, and what actually happens is that a neutron turns into a proton, but because both of those two numbers are in this 238, the two effects on the bottom cancel each other out, and all that's changed is that you've got a bit more positive charge in this new nucleus, and that cancels out this bit of negative charge that you've gained here. So charge is conserved, which is very important for physicists. And last but not least, if we emit a gamma ray, so if we do X 98238 and we emit a gamma ray, well, if you remember, the gamma ray has 0 charge and 0 mass, so that means that it doesn't change at all. But what has happened is it has got rid of excess energy. Okay, and what tends to happen is you tend to have gamma at the same time as having beta or alpha, and all it's saying is I've got rid of that extra mass that I didn't need, or that extra charge that I didn't need, but I'm left over with a bit too much energy for my new size, so it emits a gamma ray as well to balance, to get rid of that excess energy that it's got left over.